Hi, everyone. So we're here today to talk about DevOps for data science. And we should first maybe talk about the situation, the current state of AI and ML. IDC forecasts that spend on AI and ML is going to expand from 12 billion to 58 billion by 2021. So it's not a surprise that enterprises need to accelerate their adoption of AI ML technology to remain competitive within their industries. I think every product demo or announcement that I've seen from my vendors in the last year has been advertising some kind of new ML feature that's now in their product or coming very soon to their product. So if your company isn't looking at implementing some kind of data science platform that includes ML or AI, you soon will be. How do we deal with that? Is it fundamentally different from other systems that you and your IT teams have had to deploy in the past?
All right, so with the growth forecast that David's talking about, there are really two options. We can either be prepared for it and lay the groundwork for the changes, or you get left behind. So from Gartner, by 2020, more than 40% of data science tasks will be automated, which will increase productivity and add for broader usage. By 2020, 50% of organizations will lack sufficient artificial intelligence and data literacy skills to achieve business value. And by 2021, 80% of data science labs that have failed to establish measurable organizational practices will be outsourced. So what that means is we have a very short window of time in which we can become fluent in AI and ML and determine how we're going to assist our organizations in implementing a data science platform.
You know, it's kind of interesting, Tucker. I think about this like a lot of other systems we've had to roll out over the years. Whenever there's some kind of new framework for doing something that's more efficient, it feels like we're having to get caught up on it. The one that comes to mind in particular is like when CMSs got real popular, content management systems like WordPress, and then suddenly you weren't rolling your own like web server environment anymore.
Exactly.
You were implementing a framework that someone else had kind of come up with, and so that's kind of what we're talking about here, right? Is that we've got to get comfortable with what a data science platform is, what an AI enablement platform is, so that we can make good decisions about what to implement in our environment. So, which raises a whole set of professional challenges that some of which are going to sound very familiar for any systems implementation project that you're doing. So, for example, AI and machine learning ML platforms, they introduce a whole another set of jargon into your vocabulary. I don't know if you noticed this, but just Google, model definition or data science model definition, and just see how deep that rabbit hole goes. It gets really complicated real fast, and it's really amazing how many websites I've found that try to define the term model by using the word model.
Yeah, it's not particularly helpful.
So that's one big challenge. You have to get up to speed pretty quickly on the jargon, especially because your data science team, they already know it. So they're kind of running around you in meetings, maybe using that knowledge mallet to like whack you on the head and make it feel like maybe you don't know what you're doing. So got to get up to speed and very quickly.
Yeah.
ML projects are a little bit different from traditional IT projects in that, in most traditional IT projects, you're going to be the subject matter expert. Your team's going to be the subject matter expert. Or you'll have somebody on the IT team that owns that system and is really running it. Usually what we find is in data science implementations, you're dealing with another department or another team outside of IT that has most of the knowledge and most of the experience in this arena. And so you're having to delegate a lot of decisions technical decisions you might otherwise make on your own to that group. So the project can feel a little bit different than maybe a phone system implementation, for example.
Yeah, so to play off that, so a lot of times IT can feel sidelined by other business units, and that's because right now the data scientists are doing that work that we're trying to operationalize on their laptops. So they've already sort of gotten used to working by themselves. So there's a tendency to say, we're already doing it by ourselves, let's just put this into production by ourselves. And so you sort of run into that shadow IT area. And so we need to get up to speed and sort of bring that in-house so that we can avoid that situation.
Yeah, there's kind of two paths you can take with the shadow IT, right? Use the quotation marks around that.
Mm-hmm.
And one of them is you can be resistant, which is not terribly popular, I've found in my experience. Or you can take it, you can take ownership of it, and you can help produce business value for your organization, which is really the role of the IT department, right? We want to take technology and produce some kind of tangible business value out of it is what we specialize in for the organization. And just because some other team innovated something first doesn't mean that you should try to resist that. You really have to get over your hurt feelings and get it rolled out so that everyone can get back to making money for their business. So, and I think, kind of on top of that, IT always feels responsible for the outcomes of production system implementations, whether or not that's valid. We always feel that way. Things that are in production come back to us to fix, right?
Yeah, exactly. If something's broken, like who are people going to go to? They're not going to go to your data science team. They're going to come to IT, the guys with all the answers. So we need to know what's going on to be able to maintain that system.
And if you don't have all the answers, Google is right there. God, I remember one company I worked for. Our help desk motto was, if it plugs into the wall, give us a call, because we maintained like everything, like even the vending machines. I remember one day the vending machines broke, and the company owned them, of course, and so we got to take apart the vending machine and solder some components on the control board that had shorted out. So that was...
There you go. Put it on the resume.
Yeah, exactly. Vending machine repair. Actually, it's not a bad idea. And then finally, speed is everything. Speed is very important. I mean, when was the last time someone in your organization wasn't in a rush to deliver their systems implementation, especially in a situation where your data science team has been plugging away on their own for some weeks or some months, coming up with some statistical model that's going to save your company a bunch of money or optimize part of your operation. And now the only sort of bottleneck for them, the only roadblock, is getting it into the production environment. And so now you're in a situation where you've got to move very quickly to get this done because you're already on a clock and you didn't know it.
Yeah, exactly.
So those are some of the challenges that you need to get a good set of tools around in order to help you get through setting up your own data science or AI ML platform or pipeline. So let's unpack some of that jargon a little bit, just because we've already been using some of these terms and we're going to continue using some of these terms as we go forward. So maybe the first one we should talk about a little bit is data science. So data science is a process that derives key business insights from a combination of domain knowledge, software engineering, and statistics. So a key differentiator here when you talk about data science versus, say, AI, is that there's always a human element to the data science. A person is deriving those insights. You're using a computer, or you're using some code, or you're using some databases to help you get a decision made, but ultimately it's a human making that decision. And so one of the things that you have to be careful of with data science are, you've got human biases, you've got the limits of the amount of information a person can process and hold in their mind in a given time frame. So that's sort of a really high level sort of explanation of what data science is. But another way to think of it is it's sort of the evolution of what we used to call data analytics, or even just, the old reports team working with some spreadsheets exported out of your databases. It's a modern evolution of that.
Exactly.
Machine learning. So machine learning is how you're going to teach your AI to make decisions. So machine learning focuses on the development of computer programs that can access data, and then they can use that data to learn for itself. And models are, they're an abstraction of the data for a particular point of view or analysis or decision that you need to make. The models are usually statistical models or mathematical models. You're taking, a real world scenario or situation, you're modeling that, and then you're putting that model against your data and training your decision-making capability, your decision-making engine on that model. It's similar to modeling a real-world environment for a object-oriented software design, so systems design. So similar.
Yep.
Data scientists will say it's not similar, but I think for our purposes, that abstraction is useful to sort of recognize.
Yeah, for conceptualizing it, that works out well. Yep.
And then AI. So what do we mean by AI? We're really talking about machine-based decision-making. So most AI is not going to be Skynet, at least not yet.
Yep.
We'll get there, maybe, for better or worse. We got to stop kicking those robot dogs, reminds me. But most AI is not Skynet. What we really want to do is we want to enable very fast and accurate decision-making across vast amounts of data, much more data than a human decision maker could consume and make an accurate decision with in the same amount of time that a computer or a set of computers could do that. So that's, when we talk about AI, we're really talking about automated decision making. And then finally, DevOps. So why are we talking about DevOps? Tucker, why are we talking about DevOps?
Yeah, so DevOps basically is a way of doing things. So it's a sort of a philosophy, a set of practices and tools that increase an organization's ability to deliver applications and services at high velocity. So basically, from an IT perspective, the DevOps teams function as the intermediary between IT and DevOps. We are between the developers. So a lot of times the conversations that IT guys have go a lot better with the DevOps guys, so you're not having to go straight to them. So that DevOps team is really the glue that sort of makes this work. So with an AI enablement platform, that sort of helps bolster that role because it's a common ground where you can talk about the machine learning projects in a common space. So
yeah, it's so DevOps is kind of interesting, right? You might be like, why are the IT guys talking to us about DevOps? Well, DevOps from a particular point of view, I think from an IT point of view, DevOps is an IT team or IT sort of serving the whims of a software engineering group. So it's what's the movie Office Space, where it's like I talk to the engineers so the customers don't have to.
Exactly.
I talk to the developers so the IT guys don't have to. It's somebody who's trying to get the needs of the software engineering team met, so that they are they remain agile, they can produce business value, and they can get things done. In a lot of organizations, DevOps is sort of thought of as a team or a set of people that step between the aisle, between the siloed IT guys and the developers. But there's a lot more to a DevOps mindset and the tooling that's required to make a DevOps team successful. And ultimately, what DevOps is a way to function that enables your teams to move faster, and that's really important for the data science efforts. Data scientists are used to relying on several open source packages to perform their day-to-day tasks. They're used to working on their own laptop, downloading packages as they need, with a little bit of collaboration with the other data scientists on their team. So they're not used to necessarily interfacing with a large production system and standing things up in production in a way that's reliable, repeatable, scalable. And so that's where we start to get involved in the process. In enterprise environments, success in data science comes from going faster and faster. So you've got a model of operation for a data science team where they're acquiring data, they're visualizing that data, they're developing a model of the data or of the decision set that they need to make from the data. Then they're testing and training that model across a vast amount of data. Well, I guess initially in a small amount of data. And then when it's in production, they do it on a vast amount of data, depending on the decisions that they're trying to make. So most data science teams that are operating in a modern way are using DevOps practices to speed up the team. It's a way that they can advocate for automation, monitoring, and reproducibility to all steps of the machine learning, AI development and operation. from the construction to the training and all the way through to deployment. The difficulty for a data science team and why they've come to you as the IT department or the keeper of the kingdom, so to speak, for production is they need to deliver that workflow from their laptop all the way into a production system. So you need a way to do that that's more than just giving your data scientists root level, administrative level access into your environment.
Here's some servers. Get at it. That's not really going to work in this case.
I mean, it'll work for a little while, but then you get that call at 3 o'clock in the morning because something's not working.
Exactly.
So an AI enablement platform solves the dilemma of scaling end-to-end data science workflows from an individual laptop to production, whether that's dozens or hundreds or thousands of nodes. An AI enablement platform can make one-click deployment, that's a big word to try to say, operationalization. So it allows you to deploy your models very easily across a production environment using several different technologies to speed that up. In our case, we're going to be talking about how Anaconda Enterprise does this. That's the product that we're using when we talk about an AI platform. But generally speaking, we're going to use a combination of APIs and containers in order to drive that deployment across production.
Yeah, there's a lot going on this slide, but the real meat of it is the AI enablement platform extracts a bunch of that information out so that you're not having to figure out those individual pieces. The Kubernetes nodes are going to be deployed automatically within the software. And a lot of the management stuff that is taking place on the laptops by the data scientists themselves is handled for them via the platform.
Yeah, I think one of the things that's interesting to think about too is, your data science team is probably used to working in a DevOps way with sort of modern software engineering practices. They're probably using an agile methodology, and so they are going to need to iterate, quite honestly, very quickly when they're making changes and getting things stood up, or when they need to change the model. And so being able to have your AI enablement platform really model a DevOps workflow and function in that workflow, whether or not your IT team is really used to that or not yet, having it encapsulated in your platform product, in the tool that you're using, really helps you interface with that team better. Really the goal here for IT is to ensure that the things that we need that are sort of core to all of the different systems we run in production are really there for the data science team's platform. So they're really concerned about things. The data science team is really concerned about things like model development and testing and training of the model, and then managing the model. IT is really concerned about maybe from a data scientist perspective, lower level things. We're worried about making sure that access to the system is secure, that we've got good governance and package management in place over the software that the system is using, that the infrastructure of the containers or virtual machines is going to scale when we put it into production, and we can easily scale it up or scale it down. We want to be able to monitor and audit usage of the product and the system. And then we've also got concerns about high availability and disaster recovery. Those are all things that the data science platform or the AI enablement platform really needs to take into account, or that you need to take into account if you're deploying one of these tools, right? They're sort of the same things that you have to take into account for any of the systems deployments efforts that we do in IT. So you've got, if you're like us, you've got a detailed checklist that you have to run through when you put a new system into production. I think we've also got those back of the paper napkin things where it's like, okay, what are the 5 or 6 things I really need to make sure before I put this into production? And I think this is a good sort of high-level roll-up of that, right? We want to make sure we've got good change control. We want to make sure that the thing will scale. We want to make sure that it's secure. And we want to make sure that we can monitor it. interestingly, a nuance of an AI platform that is different here than in a lot of other systems you're going to deploy to production is that your AI platform needs to enable other AI toolkits. So what we mean by this is, if you go back to thinking about the way a data science team functions, is they've got a lot of different open source packages they're using, and that space is under heavy development and heavy change and heavy innovation right now. And so often they're going to be changing libraries and toolkits to do the hot new thing, or to obtain some kind of optimization within the application that they don't have today. So your platform needs to be flexible in that, if they really want to use TensorFlow today, and 6 months from now they don't want to use TensorFlow, they want to use something else, the platform needs to be able to accommodate that pretty easily. Also, the relevance of your AI platform should really apply to any industry that is out there, not really just industry specific. It'll make it a lot more flexible for producing additional business decisions for additional lines of business that you might not be thinking about today. So for example, if your AI platform is really sort of specialty focused towards the insurance industry, you might be missing some features or some functionality that would make it good if you needed to analyze some other portion of your business at another point in time. You really don't want to have to, customize that very heavily if you can avoid it in order to do that.
All right, so the biggest pain point we hear about from our IT teams and other teams that we've talked to is now we have to take this data science stuff seriously as a production system. So in the past, as we mentioned, it's sort of a Wild West situation running on desktop software or a couple servers in the corner that you didn't know about. But machine learning changes all that. So predictive models built using Anaconda at our customers make thousands of millions of decisions a day, and that old way of doing things just isn't going to work. So the pain isn't around a slick development environment, but it needs to be a governed, scalable, and easy to operate production platform. So an AI enablement platform for delivering data science and machine learning into production at speed and scale is the solution for DevOps and for data science.
Yeah, it's a difficult problem to solve, and consequently we find that customers value that solution very highly. The way that we do it at Anaconda is our platform is a combination of really providing that open source AI ML speed of development, speed of iteration on the model, that IT governance, that change control and management that IT is looking for, and then the fact that we've got these DevOps methodologies built into the system from its inception so that it operates at a cloud native scale. It'll support hundreds and thousands of nodes very easily without IT having to do a ton of legwork to get the system there. So DevOps for data science, what are some recommendations? So what's the TLDR here for our audience, Tucker?
Yeah, so the thing we've been beating on the whole time is you need to implement a data science platform. The old way of doing things just isn't going to work. So you need a system that's going to help you achieve your goals. So,
the corollary for us is nobody rolls their own dynamic websites anymore. They use a content management system, and I think that's what you're going to see with data science and AI enablement platforms is that you're going to want to use a platform. You're not going to want to roll your own. You want to have somebody else do all of the boring sort of code, right? The plumbing it up to Active Directory or tying it into your log system or connecting it to a database. The code for that, you want the underlying platform to take care of that. And then you can focus your data science team on the rest of the code that's specific to your business problems that you're trying to solve for. And I think that's really key for making sure that you're producing value for the business. It's an efficient way to use your data science team. It keeps them focused on what you want them to be doing without having them solve a bunch of problems that, frankly, have already been solved by your platform. You also, I think you really need to have a clear picture of the required infrastructure that's going to support the packages, libraries, and applications that are going to integrate into your ML models. So we haven't talked about it much because it can get very sort of
deep in the weeds.
Yeah, it gets deep in the weeds. But model management is very, very important for your data science platform. You need to think of the model as being like configuration code for your firewall, or frankly source control for your application. You need to maintain version control on it, and you need to be able to determine which versions of the model were used to produce which decisions. That becomes really critical for production systems and for reproducibility. I mean, you know, if your AI system made a decision like an instant credit check decision, you need to be able to audit that and go back later and figure out which version of the model made it and why, so that you can make sure that it's working properly. Excuse me.
Yeah, and having those sort of things in the platform is 1,000 times easier than it is doing it by yourself. So having the reproducibility and the governance in the system itself, it's as easy as saying, hey, I need to roll this model back to this date and time, and I need to try to make that decision again.
Yeah. So kind of what we've been talking about here also that extended from that discussion is, you know, you want to harmonize and tune the IT operations to optimize and be able to reproduce your ML deployment. So you want to be able to deploy out to a certain set of infrastructure now, and then grow or shrink or move that as you need to optimize for new decisions that you might be training in your system. And then, like you said, you want to be able to apply the same IT governance and control standards that you apply to your other production systems to this. So your platform really needs to provide for that IT governance. So where should people go if they want to learn more about Anaconda Enterprise? Our website is a great place to start. There's a link in the webinar about it, but we have a ton of documentation up there. You can schedule a demo of our software. Email address, I believe, is ambassador@anaconda.com if you'd like to schedule a demo. And if you just like to learn more about consulting, training, or support of our products, you can also reach out to ambassador@anaconda.com.
And of course, we'd love it if you could attend AnacondaCon April 3rd to 9th, or 3rd to 5th, excuse me, in 2019. So we look forward to seeing you there.
Awesome. Thank you so much, Tucker and David. Appreciate your insights on DevOps for data science, especially from the IT professional. It was very beneficial, at least for me, and I know it should be for our audience as well. So throughout this webinar, you guys have been throwing in your questions for us on the online chat portal, and we're going to start asking some of those now. All right, first question up we have here is, my team is already using distribution, but wanting to transfer over to Anaconda Enterprise. As their IT director, what do I need to be aware of?
That's a good question. So your data science team's already using Anaconda distribution. So really, Anaconda distribution is the set of libraries and packages and software that your data science team is going to use to get a model set up and train the model on some data and start producing some sort of preliminary results and decisions. But Anaconda Enterprise is the platform that you would use to take that smaller effort and tie it into and deploy it out to a production environment. So it does all of the plumbing work for you. It's got authentication integration. It does container deployment and management and lifecycle. And so that's really the difference. Anaconda distribution is a set of tools specifically for the data science team, and Anaconda Enterprise is a set of tools for your IT people that are going to be deploying the data science system into production.
All right, we have a next question here is, when I'm implementing an AI enablement platform, what are some of the top key things that I should be paying attention to?
Well, I think one of the things you want to make sure is you want to keep the data science team focused on the data science efforts. And what I mean by that is on producing tangible value by building the pieces of the AI enablement platform or data science platform that produce decisions and produce value. What you don't want them getting off into the weeds in is doing things like tying the system into Active Directory or LDAP, deploying containers. That's really not what the data science team should be doing. That's really what your IT or your DevOps folks should be doing. And so you want to automate that as much as possible in your enablement platform.
All right, we have a good one here. I'm not a data scientist, so how do I best support my data scientist team as an IT professional?
That's a great question. I'm not a data scientist either. I don't have the math for that. But yeah, it's similar to a lot of other efforts we as IT professionals do, right? Is you have to get up to speed on a lot of different aspects of your business that are not maybe in your wheelhouse to understand. So if you're you work at a t-shirt printing company, right? There's some tech that integrates to the process of producing t-shirts that you're gonna have to learn a little bit about. And what's the best way of doing that? Well, one of the best ways is Google, but luckily for you, we have resources available on our website. We have webinars that cover lots of different topics. We have a lot of blog articles that are written by data scientists, by product people, by IT people, that can help you get up to speed on the various concepts that are unique to data science and your data science team.
Oh, and I'm going to plug in here too, is also not to forget that we have a documentation on our website as well for everyone that is involved with the Anaconda Enterprise platform. That it's a great resource for everyone as well. All right, next question here we have. What is the main pain point, or the most common pain point that customers come to you for during the process of implementing an AI enablement platform?
That's a great question. So there's probably two. One of them is I wish my data science team had told me 6 months before that they were planning to do this, that they were planning to do this. In IT, we hear that all the time because you're usually the last to find out about some production systems implementation project that you're on the hook for doing. And you find out usually it's Q3, late Q3, early Q4, and your schedule's already booked, and then all of a sudden, surprise, there's a new project. So one of the things that I always recommend for that is, as your IT leader, you have to stay connected to the various groups in your organization to find out what's going on. And so really, it's a constant communication and constant dialogue with those teams to make sure you understand what they're planning and where their head's at and where they're going. I don't know how many times it's bitten me where somebody comes up with something last minute. So that's one thing. A more technical thing that we hear a lot is people aren't prepared for the amount of data that needs to be processed and the speed at which it needs to be processed in production. And so a common problem is that they don't meet the minimum IOPS requirements for the disks that are serving up the containers for their clusters. It's a common problem for Kubernetes implementations. It's a common problem for various containerized environments and clustering technologies. But one thing to be aware of is just double check any place you're planning to put nodes for your data science platform. Make sure the underlying hardware is up to snuff.
Yeah, it's a lot of data, and if you're trying to work with an array of 7,200 RPM disks, it's just not going to be able to handle it, and so that can be a little bit jarring on the amount of IOPS that you need to get. So
yes, especially if your data science team came to you late in the budget year.
Yeah.
So something just to be aware of.
Great. Thank you guys so much for your time today, and thank you to the audience for dialing in and listening. We will be sending out a follow-up email tomorrow by noon Central Time with the recorded webinar and some downloadable resources for you guys. And stay tuned for our next webinar coming up there in the second week of November. Have a good day, guys. Bye.